Hey, and we are live. Hey, everyone, welcome back to another CL Data Guide live. With us today, we have Alice. Alice, how are you doing this today?
I'm doing wonderfully. How are you?
I'm doing great, enjoying a peaceful morning. It sounds like you're in Oregon. I'm trying to remember, is Bend, Oregon, the coast? I don't actually remember where Bend is.
It's kind of in the middle.
Uh,
It's like southeast of the Portland airport. Of
oh,
Portland.
okay,
Yeah.
okay,
Yeah.
okay. So not too coasty, but
Not too coasty. Yeah.
awesome. Well, before we get too far into things, I'd love to get a quick background on you. I know that you've worked in real estate data at I don't actually never knew how to pronounce it. Sherry?
Cherry.
Cherry. Is it just
Cherry.
cherry?
Yeah.
Is it what it looks like?
Yeah. Yeah. It's just
Yeah, yeah,
cherry,
yeah.
like the fruit.
Awesome.
Yeah.
And then now you've kind of changed companies, but I'd love to kind of get background in terms of what you've done. And yeah.
Yeah. All right. I'll back up a little bit. So I started working in tech about 10 years ago. I was in college and didn't really know what I wanted to do. So I did the most like college dropout thing you can do, which is move to the Bay Area. And that's kind of where I discovered tech. At that time, I was actually working in transportation. So I took 2 gap years, worked at a startup that later became Lucid Motors, interned at a VC firm called Autotech Ventures. I actually saw the founder earlier this week. I was staying at his house for mini vacation. And then so around the time I was in the Bay Area, that was around when Andreessen had their big slogan that was like software is eating the world. That
Mm.
they were kind of explaining that. So actually, when I went back to school, decided to switch to software because there was just at that time a lot of hype around it in the venture capital community. But specifically, I wanted to work in data because I was like, well, what happens after the world is digitized? Well, you're going to have a lot of information to process, and so I thought that would have been a really good path going forwards. So went back to school, studied applied math, which is kind of perfect for data and data processing. And then I've been basically working at the intersection of like private markets and data for the past 7 years. And so specifically for commercial real estate and data for the past 6 years. So I tried venture data first and realized that, well, actually commercial real estate is one of those spaces that definitely needs a lot more help on the data front and the data movement than venture capital. And so yeah, it's just been a blast working in the prop tech ecosystem before at 10x Commercial and Cherry, and now I'm at a venture capital firm investing in back into the prop tech ecosystem. So it's really cool to see both sides of the prop tech world.
Yeah, okay. I have not heard the term prop tech up until now. So property tech is what I'm
Yeah,
assuming that means.
yeah. I mean, it's kind of a shorthand, but at I think originally prop tech really started out as, technology really focused on properties, but because commercial real estate is like so broad in everything that it touches, prop tech has kind of expanded to mean anything at the intersection of technology and the built world. And so I think there's lots of different examples that I can go down into a rabbit hole and but I'll let you I'll let you take the lead on this one.
Oh no, they're all good. Well, we'll definitely dive into it. Before going too deep in the data world and in tech, I do always like asking people because data is all encompassing. What do you do when you're not doing data stuff?
Yeah, well, I'm a New Yorker, and I feel like in New York there's a big running community. So I like running with a lot of my friends in Central Park, and I volunteer on my school's alumni board. So it's always really fun to not only help support the prop tech community, but also the next generation of scientists and engineers. Yeah, that's kind of what I do for fun.
Nice. Yeah,
Yeah.
running. I do always wonder what running looks like in New York because every time I've gone to New York and if I've ever run, it's a lot of stopping, is what I found.
Yeah.
And it's like you can't run continuously, which is something I'm more used to.
So the secret is to run along the West Side Highway because there's a
Mm.
continuous stretch of
Mm.
just road that there's no traffic, and then run within Central Park. So the main Central Park loop is about 6 miles.
Okay.
So it's like a 10K exactly. Yeah.
All right. Yeah, I
Yeah.
think I remember hearing about the West Highway because I heard you shouldn't run there in the mornings because you'll feel really bad about yourself because everyone running there will be like 6'5", blue eyes, finance guys.
Yes, there's definitely a lot of people that I feel like, well, I think so there are a lot of people that are very fit in New York, and I think especially in the running community, like some of these people just do like 50 miles a week and they're incredibly fit. So there's always some, I feel like in New York there's always some goal to stretch for, especially among the running community.
Yeah. Yes.
Yeah.
Um, so switching back to data, I guess one of the things you kind of brought up was like thick data, big data. Like what are these? What do you kind of view as the difference here?
Yeah. So in plain linear algebra terms or in Excel spreadsheet terms, I view big data as anything that has more rows than columns. So in linear algebra terms, that actually is an over-determined system. And then I view thick data as anything that has more columns than rows. And I think the reason why this is really important is different, at least in my world, different asset classes will fall into different types of problems. So what we typically think about in big data is like equities. So when you're buying shares in Apple, right? All of the Apple share data information, all the information about the price is available. You can find it on, Yahoo Finance, and you'll usually have many, many rows of the prices. So every hour, every day, you'll have updated numbers. But because it's a price information, there are only so many different columns that are associated with it. Um, and then when we think about thick data, this is kind of the space that real estate really falls into. And the reason is that real estate is an asset where you actually have a lot of control over the outcomes of the asset. So if you're buying shares in Apple, you become a shareholder, you get to share in the profits, but the day to day, you really don't have that much influence over, right? It's Tim Cook and his executive team running Apple. But when you're a commercial real estate landlord, you get to decide which tenants go into your buildings. You get to decide which insurance companies you work with. You get to decide which utilities, if that's an option. And so because you're making a lot of these decisions that actually impact the performance of your asset, how much cash flow it's generating, uh, that naturally you're going to have a lot more information, a lot more rows or a lot more columns about the asset that you're thinking about. And so when I think about thick data, it's not very liquid as an asset. You don't have information that's updating every day. You may have information that updates every month or every quarter, but you have a lot of different stakeholders involved that are kind of building out the columns of your data set.
Yeah. I guess
Yeah.
what kind of data do you view in real estate? Because yeah, I think that's kind of an interesting way of looking at it. Where one, the transactions that occur in real estate are considerably slower, so you don't
Yep.
have as many. But like you said, there's a lot more that goes into it in terms of other components of that data. So what data are you usually pulling in to do some form of analysis on like real estate data?
Yeah. So the best way to answer this question is kind of explain the three different buckets of data we deal with in real estate. The three buckets are public, third party, and internal. So public data we kind of think of as anything that is collected by the government. So lucky for us in the US, there's a lot of open data movements, not only at the federal level, but also at the municipal and state levels. And so a lot of that real estate data we see from that's collected from the government could be from like the census on demographics, where people are moving, how fast is an area growing. We have the county tax assessors and recorder's office. So every time you're paying taxes, all of that information is made public. And that kind of gives us information on what the government is tracking in terms of real estate information. When we look at third-party data sources, those are usually companies that have figured out how to digitize a lot and package a lot of information. And some of the big names there on the commercial side are like CoStar. CoStar actually acquired one of the startups that I was working at before, and that's more on the commercial side. And on the residential side, it's like, CoreLogic, Zillow, that most people think of. And then in the internal data bucket, those are the data that's captured by a lot of internal systems. So if you have like a property management system, all the data that comes out of just tracking property management workflows. So rents, are tenants paying? Are they delinquent? How many, what square footage are they leasing, and so on and so forth. It could also be ERP systems and CRM systems that a lot of companies use. And so when we're thinking about, all the different like thickness of the data, so how many columns we can have, it's some combination of pulling in that public data, the third-party data, and the internal data systems.
I imagine so. Like, it's probably not terribly difficult to join all that because unlike maybe trying to create a single user, when you have
Yeah.
like multiple ways that someone might interact with a website, email, phone number, etc. This is probably a little easier to join all that data together because it's like, okay, address is probably pretty easy to join on.
So you'd think it'd be easy, but it's actually not. I think the one thing I've realized about the real estate data ecosystem is whenever you think something is easy, you haven't like dug in deep enough to understand why it's hard.
Mm,
So let's take the example of having an address. So um, in New York. So I think New York is actually the perfect place to start thinking about real estate data and how complex it is, because it's like the prime example. Whenever you think about like in software engineering, you think about failure cases. New York is kind of that, right? Like, are there failure cases in New York? And if so, then maybe you should re-architect the system. So in New York, if you think about a large commercial building, that usually they'll have, if you think about a large office building, they'll have retail on the bottom and then
mm,
office spaces on top. So that retail on the bottom, every retail, store, even if it's all owned by one giant landlord, will have its own address.
mm,
And so if if you're, for example, an asset manager trying to think about how do I make the overall performance of the building better, you're tracking it at the building level, but not necessarily at the address level. So, I know most of America basically works really well by having an address because, it tends to be in suburbia where you have one address, one kind of business, but that doesn't always hold true in a lot of commercial office buildings. When we're thinking about other types of identifiers for geospatial identifiers, there's actually 4 in commercial real estate,
mm,
which is always really fun. So address, which you listed. There's also something known as a building, which is like the physical structure itself. There's also something known as a lot, which is an identifier based on tax identifier.
mm.
And then
Yeah.
there's also parcels. And so when we think about a parcel, it's the two-dimensional plot of land that is
Mm,
underneath a building.
mhm,
And where real estate gets really tricky is sometimes you can, if you're buying a single family home, usually you buy the land and you buy the property. But there
mm,
are lots of cases where you buy the property, but then somebody else owns the land and then you have to pay taxes on the land. That's a land
uh,
lease. Yeah. So a parcel is the physical two-dimensional plot of land. A lot can actually be a three-dimensional thing that kind of floats in space. So I don't know if you've heard of the difference between like apartments, condos, and co-ops. Have you? Should I go over that?
you're welcome to. I know I can know maybe the colloquial difference.
Okay. So an apartment, when we talk about an apartment, it's usually an individual unit in a multifamily building that's rented out. A co-op is a company, a company that's literally set up, owns an entire building, and when you sign a lease within a co-op, when you like are buying a co-op, you're actually buying shares in a company, which then gives you the rights to use a physical space within the co-op.
Mm, mm,
So you're not paying taxes directly to the county, you're paying taxes to the co-op board, and then the overall co-op pays taxes to the county. A condo is where the concept of a lot really comes in. So a condo is it could be a unit within a giant building, but when you own a condo, you're paying taxes directly to the county. So a lot usually refers to like a condo that could be, on the 30th floor of a giant um, residential building, and that will have its own identifier. So taking it back to like, okay, how do you join the data sets together? You can join it together on building, on address, on lot, or parcel. And the decision to join like which one to use will really depend on the use case that you're trying to solve.
mm.
So
What are some of those use cases that I guess would maybe have one versus the other?
yeah, yeah. So typically when we're looking at market level information, that's where addresses and lots tend to make a lot more sense. So when we're dealing with that kind of public data bucket of real estate data, that's where lots matter a lot and parcels matter a lot. When we're looking at third-party data sets, it's usually somewhere between a building and an address, depending on which market you're actually looking at. So in New York, when you look at addresses, it's never going to work. But if you're looking at, the suburbs outside of Dallas, because there's a lot of that urban sprawl, then addresses tend to make a lot of sense. So I think it depends on which geography you're looking at. Which like bucket of data are you looking at, third party, internal versus public data, and then what problem you're actually trying to answer, and what problem you're trying to answer is a function of which data source has that information.
Mm.
Yeah, so that's a long-winded way of saying it depends.
Yeah. No, I imagine, and in terms of like the data you pull out of these various sources, like are there any like basic examples of how someone could use them? Like, let's say like someone listening was like, oh, I'm just want to do a fun project. How could
Okay.
they kind of maybe poke at that data? I'm just curious.
Yeah, yeah. I think the example a lot of people start with is house appreciation. So you can look at Zillow, get a lot of that market information, get some listing information too, and it's like, okay, can I predict how much homes are going to appreciate um, in Houston versus Dallas or Austin? And I think that is usually that type of problem you can usually solve with one data source if that's like enough. I think when we're thinking about much more, um, let's say, more actionable data, like something that people in the industry who are actually trying to transact real estate, usually that's going to be a combination of, all right, let's look at all the public data available. So taxes, how are those going? We'll look at, flood maps from FEMA, right? Is it in a flood zone or not? As a proxy for whether insurers are there, which is a proxy for other signals in the market. We'll obviously look at the um, current prices, median prices for a lot of the assets that we're looking at in the area, as well as, rents and rates. So how much can you buy versus how much can you rent it for? And so on and so forth. And those tend to come from third-party data sources. Like data vendors tend to be a lot better on those types of information than a lot of the information that's collected by counties on taxes.
Yeah, I imagine. So is a lot of that data technically free, but it's one of those situations where it's just a pain to get?
So yeah, that depends on the source. So if we're thinking about anything that's collected by either the U.S. government, the federal
Mm,
government, or county government, Yes, definitely very painful to get, which is why there are actually companies that make it their entire business model to collect all that information, digitize it, standardize it into some sort of data model that, or schema that your data warehouse can actually consume, and then we'll resell that. But I think there's also a lot of interesting um, companies where they'll figure out ways to incentivize people to contribute data in order to get access
Mm,
to more data, and that's another way of collecting all that information. So theoretically, I think if we lived in a world with like no friction and no you know like people incentive structures, like you could actually collect all this information yourself, but it's just like very expensive and very time consuming to do it all yourself.
yeah.
Yeah. Yeah.
What do you have any companies that you think of when you think of like ones that have incentivized to collect data? Because I'm curious, like, what are those companies?
Yeah, yeah. So there's a company called CompStack. So they do lease comps. So, for every, you know, so they do it across all commercial sectors, so retail, office, um, industrial, and so on and so forth. And Comstack's model, I think, is really interesting because they are talking with the leasing brokers. So those are the brokers that help you find office space or find warehouse space or find retail space for businesses. And those brokers, it's kind of like a pay to it's like contribute to get access model. So the leasing brokers will be like, hey, I just signed this lease. It's for these terms. It costs this much. This is approximate like square footage. It's going to last, 10 years. So as a lot of these brokers are contributing information about leases, the brokers are then able to get access to the platform to see all the other leases. And then as a result of Comstack collecting all this information, they then also sell that as a third-party data source to other players in the market. It's very
Yeah,
interesting. Yeah.
yeah. I think it's always yeah, like you said, interesting to see how companies kind of convince to get more data, and then yeah, as long as you can create kind of that aggregator component,
Yeah.
it just makes it more valuable.
Yeah.
So, in your experience, like how how did you kind of use all this data, right? And like, how did you end up having to model it, since it is coming from so many different places, and you're trying to, mold it all together?
Yeah. So I like to when we're thinking about data modeling and warehousing, I like the star schema model a lot. That's kind of how I think about most things. And the star schema, for anyone who's not familiar, is you kind of have this central table that's like uh, the best way to describe it is like it's kind of the grain at which everything else around it, all the information supporting it, um, works at. I'm not explaining this very well, but
You're good.
yeah. So I always think about it as like what's the center of the star and what other information related to that star, how that works. So one option that is actually very popular for a lot of prop tech companies, especially those kind of enterprise software companies, is to have the center of the star be at the property level. Obviously, how we define property is going to depend, but they usually a lot of these enterprise SaaS companies will let the user define what a property is, because
Mm,
we have buildings, lots, parcels, and addresses, and so the property will get defined, and then all the different tables that are kind of around it in the star schema model will be attributes related to the property. So it could be like the center will be a property, and then you'll have a table for all the tenants and their leases. Those are usually split up into two separate ones. You can have the property and all of the insurance information adjacent to it. You can have all the taxes. If there's payments scheduled around all the different leases. All of that will kind of connect to the center of the star and the star schema.
mhm. Yeah,
Yeah.
I'm curious with payments, because payments kind of come in, and those are transaction like as well. So I imagine that's a little bit fact like, to a degree. So
Yeah.
that's usually, yeah.
Yeah. Yeah, payments are always really, really tricky um, because I mean, there's two types of accounting, right? There's accrual accounting and cash accounting. And I think so what's interesting is most like institutional real estate players will do accrual accounting. Whereas I think mom and pops tend to do cash accounting because they care a lot about that cash flow performance. And so, depending on who is actually the owner of these types of properties, payments will either uh, matter a lot more to how they think about the bottom line or not as much.
Mm.
Yeah.
Yeah, yeah. And then like in your past experience, specifically at like Cherry, like what were like some of the projects you were kind of trying to run? Because I think you're working more on ML, correct there?
Yeah, yeah. Yeah, a lot of the types of projects that we were working on were more related to like the market level because you get a lot more information at market level than property level sometimes. So market level, so what we mean by a market is anything from like a metropolitan statistical area, which is defined by the census. So that would be like, Dallas and all the surrounding areas, or like Denver and the surrounding areas. It's the best way to think about an MSA is like if you look on Google Maps and there's like the splotches of like gray versus green. So anything that's like a, a a network of roads and everything in that area is kind of like grayish, then that would be like the best proxy for thinking about an MSA if you haven't looked at MSAs before.
Mm.
So, anyways, an MSA is really defined as a central large city and all of the adjacent like towns and cities around it that just make it so that there's kind of like a central density of a lot of the population. Um, and so when we're looking at market level information, usually it's pretty rich because we have a lot of the census information that we can pull in, as well as market level information from third party providers. And a lot of what we're trying to do is build models to kind of think about, well, which areas are most poised for growth, so that our clients at Cherry could deploy more capital there. Um, Problems like that.
Mm. Yeah, no.
Yeah.
Um, I guess like even digging back farther into your experience on the VC side, I'm curious in terms of like what is it like working on the VC side, working in VC data? Because I think you referenced like VC data. Like what is that space like?
Yeah, I think with private markets, so I'll kind of bundle VC and real estate together into private markets. Private markets are very opaque because there's not a lot of regulation to make it public. So when we think about buying shares in Apple, the reason why we have so much information is because in order to be a publicly listed company, there's certain reporting requirements. So that's why we have a lot of information about Apple and such. So in private markets and in VC, I think it's very, very difficult to find patterns among like successful companies
Mm.
in a way that's like very statistically rigorous. I think we all have kind of mental models for what works well and what doesn't. But obviously the landscape is always changing. Like tech is changing so fast all the time that mental models always need to be adapted. So I think from that perspective, if you're thinking about, okay, like which companies do I invest in or not, it's unless if you have a very specific way of collecting information that's a lot more robust, it's actually very difficult to do things in a statistically significant way. But that doesn't mean that you can't use data to help support a lot of the companies that you're working with while you own them as a portfolio company, or you're holding shares in them as part of your portfolio. So yeah, it's definitely very interesting, and I think even the entire venture ecosystem has changed so much in the past few years and past decade. And the best way to answer that question of like, well, how do you use data in venture is to constantly experiment and see
Mm.
what works because I don't think there's a one size fits all in venture capital. I mean, and you can see that when you talk to different venture capital firms and think of, and ask them what their investment thesis is, because there's so many different ways to be successful, I think, in this space.
Yeah, I imagine it's a little bit of shifting, or a lot of shifting around, just because it's like you said, it is hard to say like, well, why is one company fully successful versus another?
Yeah,
Sometimes it is like, yeah, you'll see obviously founders that successfully set up multiple companies,
yeah.
and you're like, what is the it factor? What is it about that founder that does it? And then other times, you'll be sitting there wondering like, why is this other probably company that has all the same attributes
Yeah.
not going in that right direction?
Yeah, I mean, it's really hard. Well, A, it's really hard to even get that data to do the analysis. But B, I think this is part of the why I love private markets so much. There's so much of like betting on people, and they're and different people's like endless ingenuity to just like figure out really tough problems and get through a lot of tough obstacles. And that's something I don't think data can ever quite capture. I feel like data is always backwards looking, but if you're like really innovative and you're really creative with problems you're solving, then you can't really take what's backwards looking and apply it forwards. So that's definitely one area where machine learning tends to fail.
Yeah, is that something you've run into maybe a few times? Like, because again, like as you've deployed, whether it's on the real estate side or on the VC side, some of these various models, is that something you've kind of seen where it's like, yeah, this model said it should be good, but it wasn't, or something like that?
Yeah, well, I mean, not in my personal experience, but I remember a couple of years ago, Zillow actually stopped their iBuying business. Yeah, that's like the big example I think a lot of people point to when they're like, oh, okay, how do we think strategically about machine learning and real estate? And so, there's been a lot of papers that have come out specifically about like why it didn't work well. It's like, well, they didn't have people on the ground that and all these like on the ground observations that could feed into the model and so on and so forth. So we actually did an analysis when I was at Cherry on like median market values that were on Zillow, like Zillow publish as part of their market reports. And,
Hmm.
anybody can go to like Zillow.com, find their data and download it and look at it. And so we were comparing all of these numbers versus like, let's say county tax assessor records. And in some markets, Zillow prices would be listed like their median market price would be something like 25% higher than what the county deeds were actually listing. And so my personal take on why that didn't work is a lot of the models were trained on a subset of information than the total space of information. And what that
Hmm.
means is when you think about what it takes for a property to get listed on Zillow, it has to be a seller wants to sell. They get a broker. They sign a contract, right? The broker then lists it on the MLS and then decides to list it on Zillow in
Hmm.
order for it to be captured on Zillow. But there's also a lot of people who, will sell without a broker and they don't list on the MLS. There are people who just, buy a house from their neighbors, right? And
Hmm.
it never gets a broker involved. And so I think when we think about like how do we use real estate data, we like there's definitely a lot of scrutiny involved in, all right, what is that source of data and what are all the steps required in order for that source to even capture that information.
Hmm.
um, and so, yeah, that's just my personal take on Zillow. I'm sure lots of other people have other takes. But also, I think with Zillow, what machine learning does really well is a lot of momentum, right? So if in the prior years, Denver, where you are, has been appreciating really quickly, then the model probabilistically will just predict that it's going to keep appreciating. But what typically where a lot of the difficulty in real estate data happens is real estate tends to work on like 8 to 10 year cycle.
Hmm.
um, and when you think about the entire ecosystem of real estate data, there just isn't that much information going back multiple cycles. So if you don't have that much information that's kind of looking at the macro cycle for each market, then it's really hard to build models that are very accurate going forwards. And I think that's where model building for real estate differs from a lot of other assets, where there is a lot of large influences of the macro cycle. And I'm not saying like, other, asset classes aren't also accounting for these macro cycles, but the richness of data that tracks all of that information just isn't quite there yet in real estate. And that's why I think a lot of the human judgment component also matters.
Yeah. I was
Yeah.
gonna say, I imagine another component is just like you said, like on the macro, where what are the bigger trends that are occurring? If the stock market goes down, I think it takes a few months, right, for it to eventually hit real estate. Not only because, I mean,
Mhm.
really the big reason because it takes longer to sell that asset. So
Yeah.
even if there are distressed properties or people who are having pressure on it, they have to take, it takes time. You can't just like put a house on the market then it flips
Yeah.
the next day.
Yeah, exactly. Yeah. I think there have been numbers anywhere from like 6 to 18 months. So the overall real estate cycle is about 6 to 18 months behind equities.
Yeah,
Yeah.
yeah. Do you try to bring in some of that data as well when you're building some of these models in terms of like maybe more macro type of data sets, and then what types of data points are you looking at?
Yeah. I mean, so a lot of what we care about are like jobs numbers. I think, if you're paying attention to all the Fed, like, are the Fed going to cut rates? Are they not going to cut
Yeah.
rates? The jobs numbers matter a lot right now. So obviously, keeping track of that is pretty important for modeling. But when we look at jobs numbers nationally, that's very different than looking at jobs numbers locally, right? Real estate is like a hyper localized
Yeah.
asset, right? So, if you look back to 2008, some metros and some cities were definitely hit a lot harder than others. I think the statistic that's quoted a lot is like Dallas barely barely felt it in their unemployment
Mhm.
numbers, whereas New York got hit really badly because it was directly impacting one of the sectors that New York is that really drives a lot of employment in New York, and so back to this, like, well, okay, how do you think about what you know granularity of data to use? It really depends on the geography. Geography drives a lot of the, like, well, which sectors do you pay attention to, and which macro trends do you really follow? And I don't have like a explicit playbook. I think a lot of, like, how do you pay attention to which trends and which factors to follow is really just comes out of exploratory data analysis. So every time a new problem comes up, right, let's explore the data and try to figure out which ones are really driving this macro factor. And then let's figure out which of those factors to then check into the model.
Yeah. Yeah.
Yeah.
One of the thoughts I was having as we were talking, because you're referencing Zillow, and like people didn't, there weren't boots on the ground, so people didn't see necessarily some of these some of the houses either in person. I'm curious, with things like LLMs. I think this is one of the places I found interesting,
Yeah.
uh, because you have picture data, both in terms of like map data, in terms of Google Map
Hmm.
data,
Hmm.
and then obviously the picture that you're listing. Now I've actually have a few friends who are like developing query engines that essentially you could just write a normal SQL query to
Yeah.
run against like images, right? So
Yeah.
now you can say like, hey, show them, like, do you see that as something that could possibly improve the approach? Because like I imagine right now a lot of real estate companies, if they're doing some sort of like real estate investing or something similar, they're mostly using tabular data, right? Like to try to figure
Hmm.
out the value of a property. But if you could then also somehow create a score based on images, could that also, you think, play a role?
Yeah, I mean, there's definitely a lot of that in the single family space,
Hmm.
because you can look at all these objective numbers on paper, but I think with a lot of residential assets, how a space makes a person feel is definitely a huge part of like whether they choose to live there or not. So I think in that asset class within real estate, it's definitely very useful. And what I mean by asset class is, real estate is kind of this overall encompassing term to actually mean many different things. So in real estate, we have the residential sector, which is, multifamily, single family. Sometimes it's student housing. It's, senior housing, so on and so forth. There's industrial, which are like warehouses, data centers, and so on. There's office spaces, and obviously office spaces can vary from, very, very, not nice spaces that are just kind of like, converted homes or converted other spaces into office space to like, those high rises in Manhattan with like all glass and, everything's temperature controlled. There's also hotel, which is hospitality. And obviously, the definition of hospitality has changed a lot with the rise of Airbnb and short-term rentals,
Okay,
and so on and
they're
so
down a
forth.
little bit. So
They're down a little, yeah. They were rising and now they're down a little bit. And I think that's because of a lot of pressure on consumers right now, and the high interest rates. But so when we talk about all these different like asset classes within real estate, when we looking at features such as images matters a lot, I think, to a lot of the consumer based ones. So
mm,
multifamily, single family, um, sometimes hotels, because, we like nice things. Like I want to stay in a nice hotel, right? I don't want a hotel that, doesn't make me feel nice when I'm on vacation.
mm.
Yeah. Yeah.
Suddenly I'm curious, like, how do you tell an LLM to say, like, something along the lines of, like, "Will this hotel make me feel nice?" Or, like, I get what you say feel nice, but I'm feel
Yeah.
comfortable, feel like it makes you there's a feeling where, you feel better or worse, depending on kinda how the vibe is, so, no.
I guess it's gonna be a lot of manual data labeling of like nice, not nice, and then just like feed it back to the LLM and then get the LLM to like learn the patterns for that.
Yes, yeah, no, that's very
Yeah.
very fun.
Yeah.
And the thing is, like, even there, I imagine it can be very easy to trick because to me, I'm like, yeah, there's plenty of like when I was going and shopping for my house, um, there's like a house can look nice, but there's just things that you'll be like, yeah, it looks nice, but that's because someone just did just enough to make it
Yeah.
look nice,
Yeah. Yeah.
but it's not nice. So those are there is something
Yeah.
to that as well. So I do think it's hard to avoid not showing up to the house.
Yeah. Yeah. I mean, you have to be in the space. Like, how else are you gonna know that there's like crazy noises outside, right? I mean, that's definitely a big concern in New York because there's just like ambulances at all times of the day, and it really does disrupt your like sleep and quality of life. And so, yeah, nothing quite beats just like being on the ground and getting that feedback. And so, one thing that was always really interesting when I was building models at Cherry is, we like kind of build these models and do all this exploratory data analysis, but having the people on the ground like come back to us and be like, wait, okay, why are you selecting this feature? This feature makes no sense.
Mm,
um like this feature like isn't actually something that matters to a lot of the tenants we're talking to. And I think having that very close relationship between like the business and the folks building the models, especially in real estate, is really important.
yeah. Yeah,
Yeah.
I found the same like when I worked at a company where we were doing like fraud detection for healthcare,
Yeah.
and like it's like you could spend all day, doing some sort of exploratory data analysis and trying to find features that you think are useful,
Yeah.
but nothing beats just talking to the people who have already been manually adjudicating fraud cases for the last decade. They will tell you it's like, no, we know what the problems are, and like you said, we also know what's innocuous and what you might think looks like something that's worth digging into or looks like digging like some sort of fraud or like you said looks like a feature that's useful, but
Yeah.
it's not, right, like for one reason
Yeah.
or another, and they'll know.
Oh, for sure. Yeah, I think, as much as we believe in like the power of artificial intelligence, I think human intelligence is still much, much stronger than that, right? Because like human intelligence has been evolving for tens of thousands of years, and artificial intelligence has really only been evolving for the past few decades. So nothing quite beats like everything that's going on in our brains, and trying to learn from. I think something that's really useful is to learn from the human intelligence, figure out heuristics to then bring over to the machine intelligence.
Have you utilized any LLMs anywhere in some of your processes or finding them useful?
Yeah. So this is always really funny because I was on a panel a few months ago, and they're like, and the panel's topic was literally like why LLMs won't solve all your problems. So first of all, I that was like the perfect panel to be on because that's like my fundamental belief. I think LLMs are really great at like very finite, like predetermined tasks where you have a very clear understanding of whether an answer is right or wrong. And it's just a way to kind of do that at scale. And so examples of that are, because in private markets, there's a lot of data that's just not captured. So, information that's on, different companies' websites. What I would do a lot is, take a lot of that information and just try to kind of standardize it into data that is parsable and usable. And I find LLMs are really useful for that, and like taking a lot of that unstructured data, structuring it in a way that is interpretable. Doesn't mean that they don't hallucinate sometimes, and I have to go back and check them and make sure that they're processing information correctly. But that is definitely a use case that I'm a big fan of. Um, you know, Sometimes writing text. So I end up sending a lot of emails. So sometimes if I'm not really sure how to phrase something in emails, I'll be like, "Hey, here's what I want to say. I don't know how to say this nicely. Can you help me say it nicely?"
I don't know how to
Or
say it
like
nicely.
change the tone of this, right? Like this sounds
Mhm.
aggressive. Like make it sound nicer. Or like this makes me sound like I'm too nice. Like how do I make it more aggressive?
Okay.
And just kind of play around with that. I find that's like definitely very helpful on my day to day workflows.
Yeah, I was gonna say, like, why just be aggressive, it's okay. It's just I tend to also, I think, sit a little more on the less aggressive side with my writing style, where it tends to be like I use a lot of likelys and probablys, and I'm like, "I gotta stop doing that."
Yeah, yeah,
But I think it's
yeah,
also a little bit of, like, the engineer in me where it's like, I mean, like, in many cases, this is true, but also I know there's not always true, so then you're like, I can't say 100%, but,
yeah.
there is something
I
to that
know
confidence.
there's always, yeah, I think what's interesting is in engineering you're always thinking about like the 90th percentile, like all the cases that can happen within like 90 probability of 90%. But then you always leave room for error for that extra 10% of like, oh, these are the use cases it doesn't handle. But I think in business and in venture and in investing, confidence gets you a long, long way into getting something that and the outcomes that you want. So it's definitely a difference in communicating between like on the technical side versus the business side.
Yeah. How was it?
Yeah.
Because again, you've kind of worked on both sides, and now I think you're like I feel like when we talked, you're very much on the technical side, but I noticed that your LinkedIn says investor. So which
Yeah.
side do you play on more at this point?
I think I play more on the business side by sheer number of hours. But I do spend a good chunk of time also on the technical side. I think one thing that's really cool about a camper and which is the company that I'm at now. So Camber, as background, is a strategic venture capital firm. So what that means is we all of our investors are very large institutional players in the real estate space, and then we invest in a lot of prop tech companies, so intersection of the built world and technology. And the reason why the strategic model works is we specifically invest in companies where we can actually add value to them because of our investor network. And what that means is, if one of our portfolio companies is thinking about a new product line, let's say, and they just kind of want some beta users to help them test out ideas, then it's like, well, hey, we know these people at these large firms. They're running into this problem. Why don't you talk to them and kind of interview them to figure out, how to build that out. And then, of course, there's the typical, okay, you guys are looking for more customers. Here's an LP base who could potentially be customers. And so, when you're asking like, okay, are you on the technical side or on the business side? Obviously, I'm always on the business side at a venture capital firm. But I think what's really cool about being a camper and doing a lot of that hands-on support for our portfolio companies is I have been on the technical side. So I can actually talk to a lot of the technical elements of like thinking through product and data and all those elements.
Yeah.
Yeah. Yeah.
Yeah. What, like, I guess in terms of some differences, what are some of the differences you've noticed kind of flipping over and doing a little more of the business side?
Um, so I think on the business side, so I feel like on the engineering side, okay, let's start with engineering. I think on the engineering side, you're always trying to think about more robust solutions and scalability, right? And on the business side, you don't need that much scalability. And so one of the big challenges I've been adapting to is, whereas before I would always think about, okay, here's how you solve it for like every potential scenario. Whereas even if you're, kind of building an MVP for a product or like, and you're trying to find product market fit, you're trying to like at least address as many of the use cases as at that point. Whereas I think on the business side, it's like, okay, what is the one piece of information or what is the one next step to just push something forward? And so that's a big, I think, difference that I've had to adapt to. Some other differences are, just putting the relationships first instead of technology first. It changes completely how you interact with people, I think. Because I think with technology, if you're thinking about technology first, there's always like, okay, what is the best solution for this? There's definitely an element of like, what is the best solution in the investing world? Like, what is the truth that we're trying to chase when we're looking at investments? But that is always contextualized with, okay, how do we make sure that we're also maintaining our relationships with everybody around us?
Mm. Yeah,
Mhm.
that is definitely something I've heard a lot when it comes to more talking to like people more on the business side or more on the director level if they are on data. It's also like things need to get done. So
Yeah,
regardless of maybe there's, like you said, maybe there's a best solution, but if things can't get done in that best solution, or if they cause some issue that again doesn't get things done,
yeah,
then you might have to pick a different choice because it's like there might be a better solution, but things don't happen, and
yeah,
it doesn't
yeah.
matter if you have the best solution.
Yeah, it's better to, yeah, done is better than perfect, right? Yeah.
Yeah. So I do like that kind of idea of like trying to figure out how to work with people, which is always interesting when people have different goals and perspectives on probably similar problems.
Yeah,
Yeah.
definitely. Yeah.
Yeah. Well, I do want to be mindful of time. We have like 6 minutes left here, so I do want to open up the floor, both if anyone else has any questions who are watching, but also for you. Do you have any thoughts, any questions?
Yeah, I'm kind of curious about, so you obviously have taken so many different roles in data. Um, what's your like what do you like about what you do?
I mean, I think for me, one, the reason I ended up getting very drawn to data engineering and that space is because the work feels like you have an end result that
Yeah.
you are often attached to, where you're like, I built, something that's going to stick around, when the things on the data science or even analytical side is sometimes you build things just for that moment, right? You're just analyzing a problem. One, it can go on infinitely, right? Like you could keep digging on and there's like no stop. And then two, once sometimes that analysis is done, it's done. And there's something about that where I'm like, I want to build things that feel like they last and are a little more robust. So I think there's that aspect to it.
Yeah.
Trying to think what else. I don't know. I think there's parts of my mind that just like the work. It's like, yeah, this work makes sense. It feels not real, because I definitely have been finding other real work that's in the real world. Boring real work, which is just like gardening. But I'm like, this is so fun. It's very, again, tangible. I think I've always been drawn to tangible things that feel
Mhm.
more that, like, you can see the result. But yeah, I think also just solving interesting data problems where maybe a company is like in multiple countries, and they have got, you've got to deal with data from multiple regions, and how to make sure you can actually legally bring it all together. And then those types of problems are also fun. So I think there's a lot of different interesting problems in the data engineering, data architecture space.
Yeah. Well, I think it's really interesting that you say, how do you like legally bring things together? Because I feel like when I was working at a data company, there's definitely a lot of like, okay, you can't cross swim lanes.
Yeah.
But I think once you're in investing world, all information is consumed. So it's not so much like, oh, okay, you necessarily need to build a pipeline, and you can't cross swim lanes between these like silos of information, but you need to be able to integrate all that information together to find and figure out like what truth is. And so I think that also interestingly has been a big mind shift where it's like, okay, here's a piece of information about let's say um, a client, and then here's another piece of information about a data vendor, and they must never mix. Even if like I have both pieces of information in my head, I have to also like separate them. There's like a wall in my head too, and now it's like, oh no, every piece of information I get, I need to integrate into my mental model. So yeah, I think that's really interesting to think about.
Yeah, yeah, yeah. Yeah, and
Yeah.
it's not that, like, in some of those cases, like, you eventually want that data to come together, but you either have to aggregate it, or, usually it's because of, like, PII or something similar to that, where,
Hmm.
maybe you can't bring, European data on a person level
Yeah.
into a final system, but you eventually need to, calculate revenues and things of that nature. Um,
Yeah.
it's just more on the lines of, like, at what level can you bring that information? Where does it have to physically sit, right? Like,
Yeah.
UK data has to sit in the UK, EU data has to sit in the EU,
Yeah.
and then trying to figure out how that all that plays well, so you can still kind of query it and glean information and stuff from it, even when, because again, these companies are one company, but they have to kind of play differently based on the data sets.
Yeah.
So, yeah.
Yeah.
Cool,
Must be
awesome.
fun. Must be fun to always keep track of all of that.
Yes. But, awesome. I don't know, any other thoughts, any other feelings you've got as we kind of wrap up here?
Oh, well, I have to make a pitch, right? So, Camber Creek, we have invested in a lot of really wonderful companies. A lot of our companies are actually hiring for data folks. So if you're interested in figuring out, which roles we're hiring for, go to cambercreek.com, go to the jobs board, and all our portfolio companies listings are there. I want to make this pitch in particular because I know there's been a lot of layoffs, and there's been a lot of shall we say fear in tech space about jobs. Just wanted to let everyone know that there are still companies hiring a lot of data folks. So check out those jobs.
Yeah. Awesome.
Yeah.
Cool. Well, thank you for that. Other than that, I don't think we have any more questions. I appreciate your time.
Yeah. Thank you so much, Ben. This was really fun.
Yeah, thank you so much, Alice. Awesome. Cool.
Take care.
Well, all right. I'll hit end stream.